Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azrin binti Niklin with metric number AE3180012. So I'm going to talk about the project background for this task. Noise can be divided into two parts, which are correlated noise and uncorrelated noise. So for this task, we're going to talk about the uncorrelated noise. Uncorrelated noise is a noise that presents at all time. Uncorrelated noise can be divided into two, which are external noise and internal noise. In this task, we are focusing more to the internal noise. There are three types of internal noise, which are short noise, transient time noise, and thermal noise. This assignment is related to the thermal noise, or it can be called as thermal Johnson noise, which is the most common cause of the internal noise. In communication system, the quality of the receiver is majorly affected by the thermal noise. In easy way to describe the relationship between thermal noise and the receiver, it can be state that the lower the thermal noise, the higher the receiver sensitivity. So when the sensitivity of the receiver is high, it will increase the performance of the communication system. In order to lower the thermal noise, we need to reduce the temperature in our operation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazrin bin Mushamshidin and my metric number is AE1800058. So I'm from group 6. So for the task 1, I'll be the one that establish the pillar table. So basically there is 3 points for the this task problem. So there is a fact, idea and learning progress and action in the table. So let's go to the first point, the noise equivalent bandwidth. So the idea is to apply noise at the input power, and the learning process is gain the sequence of amplifier, and the action is by measure the average of the output power using a meter that is responsive to the frequency that is constant over the passband. So by that we can be able to measure the SNR output. So we able to monitor the system, the efficiency of the system. So the second one is amplifier arrangement. So by adjusting position in form of chamber 3, chamber 2 and chamber 1, we able to get the better SNR, so value of power gain and value of SNR output. So by arranging the amplifier from amplifier 3 to amplifier 1 respectively to obtain the higher output of SNR. So the third one is temperature. So the idea is the lower value of temperature to get the lower value of temperature surrounding the system, and the lower the temperature surrounding, the higher the value of SNR. So the action is to establish the system within the lower range temperature. For the further explanation, it will be explained by my other group member. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiqin bin Zakaria, number matrix AE1800069, and today for the problem based learning PBL assignment noise chapter 2, I will present methodology part. So this is our group project. This is our group methodology. So first, it start with identify the problem from the question and gather information based on the problem. Next is understanding the limitation from the question and the factor that affect the noise and SNR. So the data collection are such equation use low or high complexity equivalent noise temperature and noise factor. So after that is brainstorming the ideas to propose best solution based on the problem. The technical and non-technical solution will be calculated. Subsequently, choose the suitable solution to answer the question. Next, based on the computational method, if the solution is not produce is if the solution do not produce the highest SNR output, the previous step will be repeated with different variables. Meanwhile, if the value of SNR output is the highest than the other solution, the group will promptly do the analysis of the result and then continue with the discussion. And finally, the last step is to complete the report writing, and the video presentation will be done, and then submit the final report and the video presentation. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azam bin Shaidi. My metric number is AE1800037. Okay, today I would like to explain the question 1 for task 1, electronic communication system subject. Okay, from this question 1, we need to propose a solution to produce the highest signal to ratio SNR output. The given parameter is the signal input is 5 watt, the bandwidth is 400 megahertz, and the temperature is the 35 degrees Celsius. So this is the initial arrangement of cascade amplifier in the system. This is the specification of amplifiers and also the specification of the chamber. We can see here the amplifier 1 is 4 dB, the amplifier is 5 dB, and the amplifier 3 is 20. And the chamber, we have the minimum temperature, which is the 25 degree and also 22 degrees C. And also the maximum temperature is 300 and 450. So the chamber 1 don't have the range. So it 77 degrees C. So the solution is the first we need to this is the first configuration, which is the amplifier 1, amplifier 2, and amplifier 3. We need to calculate the noise input. The formula is Ni equal to KTB, and then we insert the parameters given, and then we get the noise input is 1.70016 times 10 the power of the negative 12. And then we need to calculate the signal to noise ratio input, and then we insert the signal input given, and then the noise input calculated above, and we get the signal to noise ratio input is 2.9409 times 10 the power of 12. So in dB, signal SNRI is 124.68 dB. And then we need to calculate the total noise factor. First, we need to find the noise factor for each amplifier, which is the F1 is 2.136, the noise factor 2 1.974, and the noise factor 3 for amplifier 3 is 2.461. So we total up by using this formula, and we get the total noise factor is 2.708. So from here we can calculate the SNR output. We can use this formula, and then insert the parameters, and then SNR output is 1.086 times 10 the power of the 12. So in order to get the highest SNR output, we need to arrange the amplifier with various configuration. The first one is 1 2 3, and then 1 3 2, and last one is 3 2 1. So from here we can get the total noise factor for the conversion to 3 to 1, the lowest total noise factor is 2.2078. So when we get the lowest noise factor, we also can get the highest SNR output. So the highest SNR output calculated is 1.3321 times 10 the power of 12. So by taking the minimum range of the temperature of the chamber, we can get the SNR output is 1.33707 times 10 the power of 12. So that is the highest signal ratio output, because we use the configuration of amplifier 3 followed by amplifier 2 followed by amplifier 1 and the minimum temperature of the chamber. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Wafi Taqiyuddin bin Usud with metric number AE1800025. Okay, for this particular problem-based learning PBL assignment chapter 2, I will explain about the question 2, which is the question is, without considering limitation and condition, what could the group propose to enhance the output? Okay. First, we will go to the first point with the aim of enhancement the output SNR without any restriction or limitation. It can be done by simply increasing the input SNR and applying less noise factor, which is represented by symbol F. The second one is the noise factor is easily calculated by dividing the SNR at the input by the SNR at the output. Later on, I will show the equation. And the third point is the noise factor is always lower since the SNR, which is stand for signal noise ratio at the output, is always good, which is larger. Then the signal to noise ratio is the difference in level between signal and noise for given signal level. When noise level at the receiver is reduced, the signal to noise ratio improve. And then lastly, as results, the better the signal to noise ratio of an instrument, the lower the background noise and hence the quieter it operates. And this is the equation that I mentioned before, which is the SNR, which is the signal noise output equal to SNR signal noise ratio input divided by noise factor. But if we rearrange the equation and make the noise factor as the m, we will get signal noise ratio input divided by signal noise ratio output. So as a result, we will get a more and bigger noise factor and less noise ratio output. So in this particular question, we will enhance more the signal noise ratio. So as conclusion, we'll have to decrease the noise factor to make the value of signal noise ratio output bigger. And then the second point to enhance the signal noise ratio is the actual bandwidth of the receiver, which means the wider the bandwidth of the receiver, the greater level of the output noise. This will lead to the low value of the SNR. So in order to get the higher value of SNR, the bandwidth needs to be reduced. And then to get the high value of SNR, the value of noise power should be less than the value of the signal power. And then subsequently, in order to get the high level of SNR input, the noise power should be lower, followed by the value of bandwidth. So it can be concluded that when SNR input is high, the value of SNR output will also high. Based on the formula, the relationship between noise power and bandwidth are directly proportional to one another. So this is the formula, which is power equal to K, which stands for Boltzmann constant. T is the temperature in degrees absolute, and R is the resistance of the circuit. Okay, that's all from me. Thank you.